Hello friends, myself Muhammad Furkhan, and today we are going to discuss about the first chapter, that is matter in our surroundings. So as we all know that matter is anything that has mass and occupies space. So any substance that is having mass of itself and which occupies space is called as matter. So let us discuss about this matter. So physical nature of matter. So what is the physical nature of matter that we are going to discuss in this slide? So matter is made up of many particles. The particles may be very small, may be large. So any physical matter is made up of particles. The particles have space between them. So in the first diagram here, we can observe that when you dissolve salt into water, the salt get dissolved when you mixed it properly. So this solution formed is uniform. So water is made up of water molecules, but the water molecules are so spaced, they have space between them so that they can accommodate the salt particles. That's why we say that there is enough space in the matter and their particles. In the second illustration, where we were trying to estimate how small are the particles of matter, that we are going to discuss here. When you dissolve potassium permanganate in 100 ml of water, a single particle of potassium permanganate, when you dissolved in 100 ml of water, and when you dilute it 10 times, it still gives you color. When you further dilute it by 1 as to 10, it gives color. Again, when you dilute it, the color gets lighter, but you see the color formation is there. So a single particle is there, but it is distributed throughout 1 as to 1000 dilution, which means the particle sizes are so small and the space between them is so small that they can be accommodated in large quantities also. So what we have seen in this slide, physical nature of matter. Matter is made up of particle. The particles are very small in nature. So we will move to the next slide. Characteristics of physical matter. So the matter is having certain physical characteristics. These characteristics include they have space between them, particles of a matter are continuously rotating, moving, and colliding with each other, and third property is they attract each other. So, one by one, let us discuss them. First is particles have space between them. When you try to dissolve sugar, salt, Dettol, potassium permanganate, any other substance into water, we can get them accommodated to a certain extent. So this means that water molecules are so spaced that they can accommodate sugar molecules, salt molecules and all, as we have seen in our first slide also. So this point is clear. The particle of matter have space between them. Now the second property of these particles. Particles are continuously moving. So as we have seen in this image, the particles are moving in all the directions. Randomly they are moving here and there, and therefore they may collide with each other, and the movement we can observe here that when a particle is moving, it is possessing kinetic energy. A form of kinetic energy is dependent upon the temperature for the given material. So as the temperature increases, the kinetic energy of particle also increases, and therefore their speed and their movement and their collisions will increase. Okay, this point is clear. Particles of matter are continuously moving and they possess kinetic energy. Also the kinetic energy is increases with increasing temperature. So now let us move to third characteristic of matter. Particle of matter attract each other. As we see, the particles are dispersed in this image, but they have force of attraction for them. So as they have force of attraction, the particles are keeping together. So particle forms their bunches or clumps, and that's why we can observe them by naked eyes. So particles attract each other and they form a regular pattern. Okay, so now let's move to the next slide. States of matter. So in this image we see that solid, liquid and gases, these are the three states of the matter. As in the image, solid, when you take the same proportion of this solid, is the particles of solids are spaced so closely, so tightly, that there is very minimum space between them and they can hardly move around them. When you see the second slide, the liquid of the same volume or the same area has less number of particles, but the space between them is more and they have random direction of movement. They collide with each other, they collide with the walls of container and they have space between them. When we go to gases with the same volume, we see that there are only few molecules of the gases present there and they are revolving here and there. They have very large space between them. So what are the characteristics of these three states? So solid state is having the highest attraction of forces between the particles. The particles are bound together very tightly. Particles vibrate at their own place because they have very less space to rotate around. The particles give a definite shape to the material and they give definite volume to the material. So what is liquid? Liquid state having moderate force of attraction, lesser than solid but greater than gases. Particles are moderately bound. The particles in liquid can collide with each other, can slide past each other. Because of the comparatively less attraction and forces between them, the liquid particles cannot give a complete a solid shape or complete rigid shape to the matter. That's why they acquire the shape of container. But the liquid particles or the liquid have ability to acquire the shape of the container and it gives a definite volume. So third state of matter is gases. So gases having the least attraction and least attractive forces, therefore their particles are so dispersed and they are weakly bound. Particles move around in all the direction and collide with each other. They have indefinite shape and indefinite volume. As this all the properties are clear from this image also. Let's move to the next character. So in this slide we are going to study different stage that we have different states of matter that we have seen in the previous slide. So in this slide we are going to study, can the states of matter interchange or can they be changed? So there are two mechanisms by which state of matter can change. First of them is temperature and the second is pressure. So effect of change of temperature. When you heat a solid substance, when you heat ice, ice get melt, so it is converted into liquid state of water. When you further heat water, water get evaporated, so it is converted into gases. Similarly, in the reverse fashion, when you cool down the gases, as in distillation, when you cool down the gases, gases get converted into liquid. When you keep liquid, that is when you keep water in the freezer, the liquid water gets converted into solid water, which is called as ice. So temperature can convert solid into liquid and liquid into gas. When you decrease the temperature, gases will get converted to liquid, and when you further decrease it, it will get converted to solid. So in similar fashion, when you apply pressure on the gases will get converted into liquid. Further, if you increase the pressure, it will get converted to solid. The CNG, which is called as liquefied petroleum gas. So why it is called as liquefied petroleum gas? Because the gas or the natural gas is compressed so that it is converted to liquid. That's why that is the example of the effect of pressure on it. So the gas cylinder that we use at our home is having liquid gas. Liquid, it is liquid because it is compressed so that it is compressed under high pressure so that the air or the gases get converted into liquid. Okay, so let's move on to the next slide. Interconversion of the state of matter. So there are three stages of matter. One is solid, liquid and gas. When you convert solid into liquid, it is called as vaporization or fusion. When you convert sorry, when you convert solid into liquid, it is called as fusion. When you convert liquid into gases, it is called evaporation or vaporization. When you convert gas into solid, it is called as sublimation. So there are six possible conversions. One is solid to liquid or liquid to solid. Second is liquid to gas or gas to liquid. Third is gas to solid or solid to gas. So there are five definitions. One is fusion. When solid get converted to liquid, it is called as fusion. When liquid is converted back into solid, it is called as solidification. When liquid is converted to gas, it is called as vaporization. When gases get converted into liquid, it is called as condensation. When gases get converted into solid or solid can get converted into liquid, it is called as sublimation. So let us take an example of it. We all have seen ice. When it is kept outside the freezer, it get converted to liquid. So conversion of ice into water is called as fusion. The conversion of water into ice is called as solidification. The conversion of water into gases or it is called as vaporization. And in the same way, when the gaseous water is converted into liquid, it is called as condensation. We have seen natural condensation during rainy season, and during distillation also we can see that gases get converted into liquid and we can collect it. And camphor or naphthalene are the example of solid conversion into gases, which is called as sublimation. So the matter state of matter can be interchanged or interconverted by these many steps. So let's move on to the next point, that is evaporation. Evaporation is the process of conversion of liquid into vapor. So what is evaporation? It is the process of converting of the liquid into vapor. So now we will discuss about evaporation. It is a surface phenomenon. The surface, the particles or the molecules and atoms present at the surface of a liquid, they have some kinetic energy, as we have seen previously in our previous slides. So this kinetic energy will lead to movement of the particle and collision of the particle. When particles collide with each other, the friction or the energy is it get interconverted, and if you try to provide more energy to that substance, the kinetic energy will increase. The particle will collide with each other, or they move so rapidly that the force of attraction between them will get reduced. And when the force of attraction will get reduced, they can get spaced from each other as that of gases. That's why liquid get converted into gases. This phenomenon is called as evaporation. So what are the factors that determine the rate of evaporation? Includes the surface area of the exposure to the atmosphere. Second is the temperature, then the humidity and wind speed. As the surface area increases, evaporation rate increases. Similarly, when the temperature increases, evaporation increases. The evaporation is inversely related to that of humidity. When the humidity is more, evaporation will be less. When humidity is less, evaporation will be more. And evaporation is directly related to wind. When wind is having more speed, so evaporation will be more. So evaporation causes cooling. How does evaporation causes cooling? Because when you heat a substance or a liquid, the particle at its surface will get moves from each other, and they get spaced. So as the particle gets spaced from each other, they get converted into liquid, and the area at the surface will get cooled down because the more energy particle will get released in the form of vapors. So there is one more point, that is latent heat. There are two types of latent heat of vaporization and latent heat of fusion. So let us first discuss what is latent heat. Latent heat is the energy absorbed or released by substance during the change in its physical state that occurs without changing its temperature. Which means, if you convert any substance from liquid to gases or gases to liquid without changing the temperature of that matter, it is called as latent heat. So it is the energy absorbed or released by substance during change in its physical state without changing in its temperature. So there are two main units: latent heat of vaporization, latent heat of fusion. So what is latent heat of vaporization? It is the heat energy required to change 1 kilogram of liquid to gas at atmospheric pressure at its boiling point. So at the boiling point of water, when the water 1 kg of water get converted into gases, what is called as latent heat of vaporization. Similarly, the heat of fusion is the amount of energy required to change 1 kilogram of solid into liquid at its melting point. So when you convert ice, 1 kilogram of ice into water at room temperature or at its melting point, that is around 4 degrees Celsius or 0 degrees Celsius, this is called as latent heat of fusion. So what is latent heat? It is the energy absorbed or released by the substance during change in its physical state that occurs without change in its temperature. Okay, this point is clear. So now let us summarize what we have seen in this lecture. So we have seen that matter is made up of small particles. Matter around us exists in three states, that is solid, liquid and gases. The forces of attraction between the particle are maximum in solid, forces are intermediate in liquid and minimum in gases. We have also seen that the space between the matter and the kinetic energy of the particles are minimum in case of solid, it is intermediate in liquid and maximum in gases. The arrangement of particle is more ordered in solid when compared with the liquid and least in the gases. There is no order of the particle, they just move around in the gases. The state of matter are interconvertible. The state of matter can be changed by changing the temperature or the pressure. And sublimation is the change of gaseous state directly to the solid state without going through the liquid state and vice versa. Also, we have seen the evaporation, which is the phenomenon of conversion of liquid into its vapors. Okay, friends, so this will be the end of today's lecture, and we will meet you in the next lecture. Till then, thank you, take care, and stay safe.